Hi, everyone. Let's go back to example one, our deal or no deal example. Let's say that a deal or no deal contestant has a case. So here is the contestant's case, and here's the contestant next to the case, looking a little nervous, but mostly happy. A little nervous, but mostly happy. And let X be the amount of money in the case. It's a random variable. We don't yet know what the value of X is. However, we know that we're at the point where there are only three dollar amounts left in the game: $100, $400,000, and $1 million. The contestant is mostly happy because this is a pretty good game board. So there are only three cases left in the game, and you have each of these dollar amounts in each of these three cases. One of these cases is held by the contestant. The other two cases are up on stage, and we have these models next to them, and they're smiling. All right, so one of these cases has $100 in it. Another one of these cases has $400,000 in it. And the third case has $1 million in it, but we don't know which of these dollar amounts is in which of these three cases. So let's assume that X has a uniform distribution on the three remaining dollar amounts. So each of these three dollar values are equally likely. We would think that, right? We have no reason to think that one value is more likely than any others. Find E of X, the expected value of X, the amount of money that's in the case. In other words, find the mean mu for this distribution and interpret it. So let's find E of X, or the expected value. Now, once again, because we have a uniform distribution, we could just take the straight average of these three values, add them up, and divide by 3. Or you could do the zigzag. Summation P of X times X, or vice versa. You can switch these. So we have the zigzag goes 1/3 times $100 plus 1/3 times $400,000 plus 1/3 times $1 million. When you work that out, you get $466,700. Interpret it. Here's the interpretation. If many contestants, imagine 1 million contestants. If that seems totally preposterous, think 1,000 contestants. If many contestants have the same three dollar amounts in play, namely these three, and we assume a uniform distribution, then the long-run average value of the case per contestant is about $466,700. So again, the expected value of X, or the mean of the distribution, this gives the approximate long-run average value over many experiments, over many contestants, over many plays. So if you imagine 1,000 contestants in this situation, then on average, the network will be paying out about this much per contestant. That's a lot of money. So generally speaking, the television network will generally want to avoid seeing this case, literally. It'll generally want to avoid seeing this kind of situation because this is very favorable to the contestant. That's why the contestant is mostly happy, because this is a pretty good game board. It's a very good game board. And the next offer that the contestant gets is likely to be close to this. And then you might ask yourself, would you be willing to take that offer? Or would you like to bet that your case does ultimately have $1 million? Think about that. Different people may have different responses, but would you take the money or would you keep playing? At the risk of having the $1 million revealed at some point. At some point before it's revealed in your case. You're hoping that the $1 million will be revealed in your case. But if the $1 million is revealed in one of these other cases, then that's going to really drop the amount you're going to take home. Next up, what happens if we don't have a uniform distribution? Then you don't want an unweighted average, you want a weighted average. if X does not have a uniform distribution, do not simply take the straight unweighted average. You really are going to need a weighted average, and you really are going to need this formula over here. That's next time.